Good morning, good afternoon, and good evening, everyone, wherever in the world you may be joining us from today. My name is Francesco Del Carpio, and I am the CFAL York Operations Coordinator. I would like to officially open the 14th session of our VR/XR Training and Education Knowledge and Experience Sharing Speaker Series, presented in collaboration with the DEXAR Lab at York University. I will begin with a land acknowledgement. We acknowledge and recognize that many Indigenous nations have long-standing relationships with the territory upon which our campuses are located that precede the establishment of York University. The area is known as Takaranto and has been caretaken by the Anishinaabe Nation, the Haudenosaunee Confederacy, and the Huron-Wendat. It is now home to many First Nation, Inuit, and Métis communities. We acknowledge the current treaty holders, the Mississaugas of the Credit First Nation. The territory is subject to the Dish with One Spoon Wampum Belt Covenant, an agreement to peaceably share and care for the Great Lakes region. As this is an online event, our participants may be joining from various locations, and I strongly encourage you to learn about the traditional land upon which you are located. With this, I welcome our moderator, our speaker, and our participants from around the world. Welcome to our webinar. Without further ado, it is my great pleasure to introduce our moderator, Dr. Ahmed Mohammadi. Dr. Ahmed Mohammadi is a postdoctoral fellow in the Department of Civil Engineering at York University in Toronto, Ontario, where he received his PhD in transportation engineering. His research focuses on applications of virtual reality in transportation safety, traffic conflict analysis, and traffic microsimulation modeling. His research contributes to improving transportation safety and efficiency. Ahmed is also the coordinator of Disaster and Emergency Extended Virtual Reality, or DEXAR Laboratory at York University. Dr. Mohammadi, thank you very much for moderating today and for help with your ongoing help and collaboration in this series. The floor is yours.
Hello, everyone. Welcome back to another event. Thank you very much, Francesco. Today, we have another interesting topic about virtual reality for natural hazards and risks in education and training. And we are hosting Dr. Ali Asgary, who is an expert in disaster and emergency and business management. He has been actively involved in research, teaching, and professional activities in this field since 1993. His research has been published in leading disaster and emergency management journals, including Disasters, International Journal of Disaster Risk Reduction, International Journal of Disaster Science, Disaster Prevention Management, Environmental Hazards, and Emergency Management. He was among the founding faculty members who started the first university program in disaster and emergency management in Canada at Brandon University in 2003, and later on among the founding faculty members who started disaster and emergency management at York University. He also served as IAEM Canada president between 2007 to 2009, and at the same time as the board member also during the same period. He has also led as a main person or principal or co-PI basically, and collaborator in large number of research projects funded by different agencies, including ANSARC, GID, SSHRC, NFRF, ORF, Transport Canada, Public Safety Canada, Wellcome Trust, IDRC, and DRDC. Since 2015, Dr. Ali Asgary has been the Executive Director of York University Advanced Disaster Emergency and Rapid Response Simulation, which is ADRSIM. His research interests include post-disaster recovery, reconstruction, business and risk assessment, disaster and emergency simulation and modeling, and application of artificial intelligence and extended reality, and also GIS in disaster and emergency management, and cost and benefit analysis and decision making under uncertainty. Okay, thank you very much. Without further ado, Dr. Ali Asgary, here you go.
All right. Thank you very much, Dr. Mohammadi, and thank you very much, Francesco, for the opening of the session and introduction. And thank you all for attending today's session of our speaker series. It is my great pleasure to be with you and share some of the works that we have been doing in the past few years at York University around virtual reality applications. Uh, Naturally, because I'm doing disaster and emergency management research and teaching, what I'm covering today is going to be gearing more toward this field. And I'm selecting three of the works that we have been recently working on as case studies for you, and hope that I can get your feedback and share some of the lessons that we have learned uh, with you. So basically, I'm going to provide you with a very brief background about some of these works and to some extent about how VR is used or can be used in virtual reality in disaster and emergency management, sorry. And focusing mainly on some of the opportunities and challenges that use of VR may have in disaster and emergency management or hazard and risk education and training. And as I said, giving you some insight from three cases that we have been working on in the past few years. This work or some of the works that I'm presenting to you are based at York University Dexar Lab that mentioned by Dr. Mohammadi at the beginning. This is a laboratory funded by CFI or Canadian Foundation for Innovation. And as part of GELF program that supports creation of laboratory and paying for the cost, which is also supported by Ontario Research Fund as well. As part of that, also we have this research is based at Anderson Lab that is also funded by Ontario Research Fund. We do a number of activities in these labs, but one of our focus area is use of virtual reality or developing virtual reality applications for disaster and emergency management and health. Although I really don't want to go into the technical aspect and probably detailed research component of application of VR in disaster and emergency management, I want to draw your attention to the fact that this has been an area of research as far back as 2000 or even before, basically since computer or use of computer and computer-based devices started maybe going back even to 90s, where different applications and discussions of how we can use virtual applications or beyond the current exercises and experiments, real world experiments, mock models, etc., using computer models. So this has been in line of research for now decades. And over time, we see an increasing trend in use of this technology and development and research around this. As you can see in this graph here, this is a very, of course, simple chart based on what you can find in Google Scholar or published papers in Google Scholar that has a component of these keywords. And I'm sure if you dig into the literature, you will find even more in terms of particular focus areas or particular areas within disaster and emergency management that has focus on use of VR. And when we say virtual reality, of course, it is also very wide. It covers a lot of different technologies, approaches, and methodologies. So it's not just, for example, what we will be focusing on headset VR applications, which is relative to other applications is quite recent. Let me start with giving you some general observations based on these past research and my own experience as sort of conclusion before I get into those case studies. Basically, I can summarize those into some opportunities and some challenges, especially when it comes to disaster and emergency management, and in particular, hazard and risk education and training. Some of these, of course, can be applied to other fields. It's not unique to hazard and risk, but there are specific items that I could see based on my experience and based on what we can see in research are really more applied to our field. First of all, I mean, virtual reality provides possibilities for modeling and visualizing real world phenomenon that we can not observe or be involved with or create them, mostly because of the high risk that they have, or even impossibility of involving trainees in some of these, even if you have chance to work and use real world situations as your training material or training scene, it is not really possible. It involves high levels of risk, which may not really justify using those complicated, high risk environments for training. And we already, I mean, those who are in the field already know that even involving professionals who are, high-end professionals who can be involved in these situations are sometimes prevented because of the high-risk situation. So let alone involving trainees to learn from them. So in our case, in our situation, VR applications or use of VR can help a lot in basically the way we are not able to use real world, unlike conventional functions and operations that involving or using real world situations for training is possible and has limited or no risk, basically. And there's also for many of us, I'm sure, especially if you are in the field, obviously you can see that even if we want to use some of these incident scenes or situations for actual training, we are limited in terms of accessibility to them. Most of these zones are really limited in terms of access to those who can respond or can manage, etc. So it's not really possible. Although for this case, I'm focusing mostly on emergency disaster situations, but beyond that, of course, we may be on normal situations. And it's also some disasters are often infrequent and in real events, large scale disasters that we deal with mostly. So in a community where I'm teaching or I have my school, that I can take students or trainees to go to an event is not happening very often. So but you need to continue your training. You cannot rely or wait for something to happen and use that as an opportunity for training. So you have to create scenarios. You have to create, in the past, of course, like what we do in tabletop exercises, we imagine mostly what was happening. But using VR, you can create frequent disaster scenarios and use them for training instead of waiting for actual events to use them as training materials and environment. Also developing and using real-world training and exercises in particular are costly relative to the current state of VR applications. I'll give you some examples. And there are, of course, liabilities involved if we want to use some of these real situations or even functional exercises where we are not dealing with real emergency, but we are creating fictional emergency in real world to use that as training. Still, that involves some levels of risk and liability if you want to use that for training, especially training, like especially what we do at the university, taking, for example, university students to areas like that for training. It is even different from when you take, for example, firefighters in such training situations and conditions. We also, I mean, there are some other elements that provide opportunities in terms of skill performance. Research has been conducted all over, even within disaster and emergency management and health domain, that shows, skill performance when you have exercises conducted or practices conducted with and without virtual reality are quite different, and skill performance is better when you have VR component added to your existing training and exercises. And same with user satisfaction. We get better impression, better satisfaction from users when they can better visualize and imagine the situations that they are being trained at or for. It is also lower stress because they all know, although it creates the environment and feeling that you are in the immersive world, but it gives those kind of feeling. But at the same time, they already know that they are not going to be under stress or risk from that angle, so that they are worried about something happens to them and so forth from the actual running of the exercise or the scenario inside the scene. And finally, what is important for especially work for me a lot is that, as you know, many of us are, especially these days, we are doing online training, online education. We do not have much choices to bring in students in even a space to work together in real world, let alone some of those functional elements that you need to create to have a realistic scene for your training and exercises. In those cases, virtual reality works nicely in still running your online courses, running your online training, but adding an element of reality and exercises within the reality, virtual reality that can, to some extent, compensate for that lack of face-to-face exercises and activities. And as I said, one of the main reasons for me coming into using virtual reality first in computer-based virtual reality back in 2009, 2010 onward, and now going into VR is mostly because I'm teaching online some of my courses, and I need to, still have those learning added to this virtual learning. I mentioned about the cost. There are lots of studies, but I found this study published recently to be a good example of cost when you do an exercise, for example, in real world versus an exercise of the same type and kind that you do using virtual world or virtual environment. This provides some good insight. You can take a look at the paper itself, but generally speaking, they found that for this particular case, that is hospital evacuation training, if you do it an exercise, live exercise, it costs you, for example, I mean, there are different elements of the cost, 7,000 versus 10,000 for VR, but the cost per participant, for example, $229 per participants for live exercise where you have 115 for per participants per VR. The final point from this study is that while the initial cost of VR development is relatively the same or higher than a bit higher for virtual training, over time, it's going to be much less for VR relative to the actual exercise, because for actual exercise you keep repeating the same cost, but VR, once you develop the application and purchase the software hardware, you are done with most of the cost at the beginning. Now, going into the challenges, and there are a lot of challenges again for every use of VR in every type of training. But for as with regard to emergency and disaster management or hazard and risk education and training, there are some that I have listed here, and this is not really limited to this. By no means this is a comprehensive and exhausted list, but these are some that I have faced myself in this area, and I can say or talk about them. Well, access to technology is probably a challenge. Access to technology, we mean access of those who need this kind of training. So mostly, still, it's costly. It's not something that average or low income families can get an access to it, or even communities. Let's say. So this is as such, it is there are equity issues here that we need to consider, although we already we understand that research wise, development wise, we have to continue developing, creating this content and technology so that over time it becomes low cost. And it has been the trend actually, that the devices that we used to buy for above 1,000 is now above 500. So over time these things can be resolved, but we need to keep that in mind, that it is not easy access to all for now. And also there are technological limitations, especially in our field. We are not talking about, for example, simulating or visualizing a car accident and a scene, or a building fire scene, or and so forth. So we are talking about a large flooding impacting, for example, a town or part of a city, a large train derailment impacting, significant part of a community or environments. For these kind of large scale emergencies, still we are at the beginning. Still we have some complexities and technological limitation in terms of devices being able to handle large scale data processing when you are using for example, headset, as well as the speed that you want, and even some of the scenarios that you need. So it will take some time for this technology to become fully functional within the emergency management, or a scale that we are looking at. And also there are generational gaps. Currently, although technology exists and we have started using this, but it's not received as well within the generations that are involved currently in disaster and emergency management. Most of the field is now, or in terms of occupation, it is within the emergency management generation that have not been exposed to this technology, and so adapting this technology may take a little bit of time, which is to me, I call it generational gaps in use of technology. Over time, this may become easier as we now see our younger generations coming from high school or just coming to the school, learning about these technologies. They may be able to better utilize it in the future. And cost is still an issue, as I said, although cost relative to existing training, it is better, but still it is something that you should consider. We should consider. It is not probably something that every community or every emergency management office can start running, buying those right away. or even emergency training facilities or centers. Training length, it is also a problem for most of emergency exercises, things that we do, as we all know. These are time consuming functions. Some of these exercises that we do, they are a minimum of half a day or a full day. So you cannot really use some of these devices on your head, for example, for a full day. And this is not meant to do. And there are ways not, not needing that. But I'm saying that still, if you aim to develop applications that cover all the, larger scale everything, and you want people to play and use that, still there is a limitation on how long you can have these devices, especially if you're talking about headset-based VR relative to others. That's an issue. I hope I've been able to explain that. And group training. Most of current VR applications are not, especially again using a headset base. They are not group or multiplayer activities. They are all, not all, but most of them are single player training materials or applications at this point. While we know emergency management is a teamwork. For visualization, some of these may work, but for collaboration, team building, and some of the things that are common in hazard and emergency management, this may not be really at the level that we want at this point. And finally, lack of quality content. One of the key issues, I think, VR technology and those who are behind developing the hardware part is that there are good hardware, but there are not many good applications, and there are reasons for that. I'm not going to details of that, but what is important is that having good devices without good content, especially in a specialized field like disaster and emergency management, it makes them useless. So if you buy these devices while you don't have, or you can buy the applications that you need from potential vendors or suppliers, and you don't have the capacity to build those applications yourself, you are stuck with the bunch of hardware that you have purchased but don't have use for them because there are not much content, quality content. I mean, that's why some of our job or in our lab is to mostly focus on creating contents that help this process. So I'm trying to go now into some of those cases that I mentioned without spending too much on the introductory parts. So I'm basically going to focus on some of the VR headset based applications that we have been working on in the past few years. We have been working on a number of areas on road safety, for example, on hospital care projects, as well with UHN and our colleagues there. And some, of course, hazard-based applications that I'm going to focus mostly on those right now. Natural hazard, I mean, volcano, tornado, and landslide. But we have been working also on VR, computer-based VR applications. I've been using them in my teaching a lot over the past few years, and that's not my focus for today. Now, the first application I wanna explain that for you briefly is an application that we started working on it back in 2017, 18. But based on an experience that we have been dealing with in one of the volcanoes in Italy. It's called Vulcano Island. And we have been taking, of course, led by University of Geneva colleagues in volcanology and risk and geological risk group, that I was part of their field trip to this place where I used to conduct emergency exercises or volcano emergency exercises since 2010 for over a decade. we realized that one problem that we have when training our trainees is this lack of visualization capacity, because we were basically talking about different scenarios of eruption of this volcano. But the problem was that imagination of these eruptions for public and trainees at different levels was really difficult, especially because some of these volcanoes, and this one in particular, is one of the volcanoes that is active and people see regular activity in a daily basis, but it hasn't erupted for their lifetime. In fact, in this case, 130 or so, 20 years, 30 years now from at this point, that hasn't erupted. So people have not much, or people and also expert visualization of how it look like if eruptions of different types happen. So we started developing a VR application that takes care of that, visualization of different types of eruptions for this one. And this is in, as I said, in Vulcano Island, that is in southern Italy. There are several islands here, 7 islands. They're all volcanic, and this one is hosting or housing an active volcano. And this is the main crater of the volcano. This is called La Fossa. And there are, of course, a couple of volcanoes here, and the whole island is a volcanic structure anyways, as you can see from the structure itself. And as I said, this is in southern Italy, in Sicily area. And this is the look from the top of the crater. This is the city. And what I need to tell you is that this wasn't a city or town developed like this back in the previous eruption, which happened in 1890 period. About a year, it took over a year, the eruption. But now it's almost fully settled, of course, mostly for touristic area or activities. And they are basically this site is here. You can see these populated areas or developed areas are here, and like in the outskirts of this active volcano. So if there is any eruption, there's no way that these places can sustain without any harm. Whatever scenario you can imagine, this is mostly going to be impacted. So there is a need for evacuation. So our effort was basically to visualize some of these for people, tourists, and others, and emergency managers, as kids at this school, and our own trainees who we used to take them there to better visualize this. And this is, as I said, part of a regular yearly annual training that we had. We used to take students and other professionals dealing with volcanic hazard to this island to focus on hazard and risk assessment in the island, visiting the hazard, studying the hazard, studying the vulnerability of people, and also working with local schools to teach kids about this particular volcano, different types of eruption that it may have, and you see also parents coming to learn about the volcano, and sort of community-based activity as well as professional activity that we have been doing this island with our colleagues. And you see this some of the presentation made by our participants about their observation of the hazard. And you may actually, some of you may know Misha here, who was at the time a master's student at York University and attended this field trip. So for this one, like many other applications that I'm going to talk about, we basically, as you see, this is a large island. So creating a VR application for this is not easy, and probably the quality that you want, especially if you want to focus on the whole island. So we had to start with creating the environment, the cave using the 3D model, turning that 3D model into a mesh that can be then covered by photorealistic images of the island, and then adding the simulation scenarios to it and creating the VR application interaction and interface. We started this with Microsoft HoloLens first, but now created a version of it that is running on Oculus. And in fact, is much better than HoloLens now. So this is the look of island as you can see it on real world from the photographs, and this is what we created in VR environment. As you can see, this is sort of capturing the topography, but it's not necessarily as good as you can see in this real photos. But it captures most of the elements that you need to have in visualizing the eruption scenarios. The main area that we focused for our VR application was the port area, and where the most people have some clue about this. Everybody in the island has visited, has been, and has worked or passed through this place. So putting the VR, player on one of these areas, this makes them, easily able to identify where they are in the island and where they are looking at from that angle. So as you can see, this is the real photo of the area, the port area. This is what we created. This is actually capturing this road here and the walls here, and also the hotel that is in the area. This upper floor is upper image is an actual image, and this is what we created in 3D. Just some of these elements. We created the most of the port in 3D model like this, but we found it difficult for rendering when you are using device independent from computer. So we actually removed or created a version of that has some elements, 3D elements, but not too many, so that it slows down the application when you are not running on computer. You see on if I'm running. This is the actual scene. This is our visualization of the same. We call this normal activity of this volcano. There are some gassing and fumaroles going up, and this is the simulation in VR. You can see kind of similar. We try to match everything relative to the real world case. And these are eruption scenarios that we developed for visualization. There are this volcano, as we were told, as can scientists suggest, that can have different types of eruptions. Could be a single Vulcanian eruption that is actually named after the same volcano, and other volcanoes may have the same behavior. This is called single eruption. It erupts and ends quickly, one eruption. This is actually the image you see here is the actual eruption in 1989 and 1890, like as I said, about 130 years ago. And this is another type of eruption. Again, simulation. This is what call it Plinian eruption that has both, columns of eruption as well as plastic materials coming down or collapsing. This one is another scenario. We call it long-lasting Vulcanian eruption. This is an eruption with some lava produced because this is running for long period of time. This is called long-lasting eruption. Or this one that is what is called a Strombolian eruption. Again, now when you are wearing the headset, you are in the island and you can nicely visualize some of the impacts, some of the areas that is going to be covered under this particular scenario, and feel this ashes fall on you when you are wearing the headset. So that's sort of give a much better visualization of some of the things that we were talking about. This volcano has this type of eruptions, and this type of eruption looks like this. But now they can really wear the glass. Even tourists can wear the glass, see what kind of eruption this volcano could have, both from science perspective as well as hazard and emergency training perspective. So I'm going to move a little bit faster. This is again based on when I said Strombolian eruption simulation. This is a picture that I took or a clip that I took when I visited the volcano itself, the Stromboli, on top of Stromboli. This is the Stromboli, and this is what we simulated as a scenario for this island, which is a Strombolian eruption for Volcano Island. So try to capture the reality of how it looks like based on science. The second application I want to briefly mention is this one. That is, sorry, the title should be landslide. This is simulation of or visual VR visualization of a landslide eruption. You can also call it eruption. We are about to publish this in a journal we have submitted, but we are hoping to publish the paper of this also soon. Very briefly, this is based on a study we were involved in Malawi on public health issues, but over our period of visit there, we also happened to see the impacts of Hurricane Freddy, or cyclone, they call it, Freddy in southern Malawi, that created a trigger for us to also do some work on landslide, particularly developing this VR application based on that landslide. These are the hurricane or cyclone passes impacting Eastern Africa. Most of it is becoming larger. Most of them are becoming larger and going further down into the continent, especially impacting Malawi due to climate change impacts. Malawi, because of that and other issues, including deforestation and the environment that they live at, they're subject to landslide hazard. This is a landslide hazard map for the Malawi, southern Malawi part, and as you zoom in, you will see many villages. These are buildings basically. You see many villages, etc., are within or on top of high risk landslide areas. In March 2023, unfortunately, there was a cyclone Freddy impacted Malawi, southern Malawi. I'm sure you have seen those in the news. And unfortunately, some of the secondary hazard associated with the cyclone was landslide. That especially in southern Malawi, the cities and villages were impacted by many of those landslides. This is one of those landslides that happened in and impacted one of the villages. Basically, as you can see here, a significant portion of this village was buried under debris of landslide that started from here and went all the way down the hill. And this village was, see, this area is almost not covered by anything. This was the continuation of this village, and this is the road. And so there were houses here and houses here, and they were all buried and washed away based on this. So what we came up with, say, how about if we visualize this in using VR to also ask scenarios of potentially explaining why this event can happen and how we can prevent it, if especially minimize the impacts. We may not be able to prevent them 100%, but we may be able to still minimize the impacts by certain actions, particularly with regard to vegetation and so forth. So same approach. We basically created the environment, developed the scenario, the simulation of landslide, and then develop the interface and start testing the applications and make it ready for use by end users. And these are the couple of scenarios here that I'm running it fast. This is the same area that we are talking about in the actual volcano, actual landslide. You see the landslide started from here, came to the village, and then this is for one of our scenarios. This is for another. When you have more vegetation, when you have less vegetation, you see the different types of impacts. That was the essence of this sort of training that we were looking to give more general public a better understanding of how different approaches can help reduce the impacts using an actual event like this. The last item I want to also briefly talk about is an application we created back in 2022 for as part of our involvement in disaster camp, where under school students are provided with an opportunity to learn about different types of hazard. Francesco and I were working on creating this application for the mostly for public education purposes. Basically, what this app does is that when students wear the device, they come into a neighborhood high school, and in that soccer field, players are playing, and they go through a quiz that visualizes some of the extreme events like hail, like thunderstorms, etc. first, and answer some questions. As they are involved in this process, at the end they will observe a tornado coming from some part of the neighborhood, impacting the field and also the school, and they're supposed to take shelter inside the school or in a safe place inside the school. This tornado seems to captures realities of what an actual tornado does, but our goal was really for that purpose. And this is where we were teaching kids about this, and also using the VR application to raise awareness about the potential impacts of a tornado. And again, these kids and many of us have not really had a chance to see a actual tornado from firsthand. What we have seen probably is on books or on videos of others, but imagining yourself being in an area where a tornado with noise, with debris flying all over, coming to you, and you need to find a way to save yourself. This is giving another level of learning to students and participants. So that is what we have been doing. And this is also built for Oculus device, standalone. We noticed there are some gaps in some of this. We need to optimize this in terms of the simulation elements that we have, but overall this functions that way. And we have been using this kind of activities and VR related efforts in public education. These are some of the images we had from last year Emergency Preparedness Week. We aim to have the same this year also as part of York Region Emergency Preparedness Week, using different activities, including VR based public education training. And with that, I also wanna, before I finish, I wanna let you know that we are running a VR open house. Many of you already know about this, but please, if you haven't seen this or before and you are living in GTA area, you are welcome to attend this event on Tuesday, April 30 at York University from 1 p.m. to 4 p.m. We would be very happy to have you and also see you in person. And please distribute this information to others who might be interested. We warmly welcome all. And with that, I conclude, and I'm sorry if I took too long, but still, I think we have 10 minutes for Q&A if there are questions and comments, critics about the works. And with that, I'm gonna stop my PowerPoints and get to your questions. Ahmed, back to you.
Thank you very much, Dr. Asgary. So if there is any questions, you can ask. In the meantime, I have many questions. So yeah, one question is, what do you see in terms of the future of virtual reality inside the university? So these days, still I am feeling that professors in the university, especially for in their courses, they are struggling, they are thinking, but they don't touch, for example, the VR materials. And then what are the challenges if someone wants to?
The key challenge or there are many challenges, but some of the key challenges is, as I said, there is a gap between the technology and the end users. If you want to have a technology that is easy to use for all, I can say VR is not at that level yet. It will be soon, hopefully, but it's not there yet. And because of that, it's not like a cell phone or your laptop. You put it on the plug, you plug it in, open it, and there are some softwares you start using it as you do in many, as we do it in all courses. Even so, I would say even use of a laptop took some time, or some of the software that we are using, like PowerPoint, Microsoft Word, etc. We spent some time learning them. But this learning for VR it hasn't happened yet, and partially because not everybody feels that they need this technology, and partially because maybe they have not been exposed enough to see that this is like other devices. You can if the application is there, you can vary it. You can click on some items, open it, and run it and use it. So we need to get to that point where everybody first of all has access to this, and that's why we do this VR open house to make it available, easily accessible for people to try it, to see it. It's not difficult. You can do it. But as I said, one other challenge is the content. Even if I tell you, this is very good technology, this helps a lot, this and that, unless you have really good applications for them, it's not going to work. I see, of course, over time, like some of these companies that are coming to our open house event, they are developing really good contents, and they are received very well. And I see also, other companies are now developing contents. We are in that time frame where development of contents are quite getting serious, better to say, but maybe even not at the point where a person can go and shop them as they wish at this point.
Okay, so great. We have three questions. So first question is Human Razavi. Professor Asgary, your presentation was incredibly insightful, and congratulations to your team. Generative AI is truly transforming various research domains, especially those burdened with the expenses of real-world data collections. Through data synthesis, it facilitates the generation of novel scenarios. Do you have any planned project on how to integrate generative AI and VR within the training disaster management?
Okay, this is a very, very interesting question. Thank you, Human, for asking this. And I believe it or not, if I open my Unity project right now, you can see a number of experimental projects that I've been working on, trying to include ChatGPT, for example, with VR application. This has huge applications here because there are a lot of narratives that we need or explanation for each of, everything we do in VR. With regard to disaster and emergency management, I give you an example of my own experience. When we were developing the volcano eruption, we basically had to create some narratives, explaining what each of these scenarios are. As you see and observe the eruptions, there is also a clip, a voice clip that explains what this eruption is, etc., etc. What are the components? What are the impacts? But with ChatGPT and this kind of generative AI, you can create those contents and interactions much more, in my view, better and create a dynamic interactions and so forth. So thank you. Yeah, that is what we are now shifting to, and I have seen some application based on that, and it is going to be a quite impressive future for VR applications.
Okay, thanks, Human. Next question is from Joseph. Thanks, Professor Ali Asgary. I have a question about the method used to simulate materials and the interactions with the elements in the environment. I mean, lava, landslide, water, how this interaction works.
Okay, this is also a good question. Thank you, Joseph, for asking that. At this application that we have developed, there is no interaction between users and the scenarios like hazard themselves. But I think this could be an expansion or extension of this. For the most part here, the application allows users to select from the scenarios on the menu item that is there and run the scenario, and whenever they learn, they just go to another scenario. There's no direct interaction with each of those elements. But yes, it could be. I imagine, for example, situations where people can actually click on or gaze on particular item or hazard and get more information about the hazard type. Exactly, and thank you very much for suggesting that. This could be a good extension of this.
Okay, thanks, Joseph and Dr. Asgary. Another question from Jen. In your opinion, with all the challenges in mind, what would be the future of VR? Possibilities for mixed reality?
Mm-hmm. I think like any other technology, it is getting matured, and with the new devices, better devices, faster devices, this becomes like all other technologies that we are now using, but it has its own, I believe, niche in terms of where are the best places for using these applications and training. I cannot claim or say that it is good for everything and it is good for the whole component of your training. There are elements of the trainings, as I said, for example, especially when you want people to practice actions before they virtual actions before they do real actions. There are a lot of applications here when you don't want to waste, for example, your materials, your time for teaching people how to use some of the equipments, how to use some of the processes. They can go there, train without spending money for materials, or spending money for equipment, risk-free time, et cetera, et cetera. And then they come to use and work on a real hands-on activity and training. Then they already have learned, although it hasn't been real, but it has been real enough for them to be able to quickly and much faster and with a better performance use real object. And my friends and colleagues attending this session from medical team, that is very important for them, for example, where you want to have medical students practice some of these functions and operations on virtual world with virtual equipment, etc., and patient. And once they are confident that they have learned enough, they have practiced enough, they can then go much faster and better in using and working with real patient. I have to summarize my responses. That's one of them. Yeah.
Another question from Brian is, do you allow other others to use your simulation?
We have not posted this online yet, but we will be soon at least offer and post two of these, particularly the landslide and the volcano on some of these places. We use Oculus, so we will be hopefully posting them on the Oculus or Meta virtual, as many others do as their lab projects. But if you want to contact me personally, I would be happy to help with that.
Okay, I hope that answers the question. Thank you very much. I think, yes, we are one, and then there are no more questions. Yes, okay, so then thank you very much, Dr. Asgary, for presenting the works, and then also all the participants, also those are that ask questions, and then Francesco. Maybe Francesco and Ali Asgary, do you have, Dr. Ali Asgary, final words?
No, thank you very much. Thank you to you, and thank you, Francesco, and thank you all participants for attending. Be in touch if you need, and happy to work with you. Thanks, Francesco.
Yeah, thank you very much. I just want to echo my thanks. That was a great presentation. So thank you very much for sharing all the work that's being done at York. In this regard, thank you, Dr. Mohammadi, for your ongoing support of the series and your help putting this together and for moderating the session. And thank you, of course, to everyone in our audience who constantly participates and comes to these lectures and who asks questions. It's great to have you all here. And as Professor Asgary mentioned, if you're in the GTA next week, come by for the open house. It'll be a great time. And we'll be showcasing a lot of the work and the training that's available through VR. And just very quickly, I'm just going to share my screen one last time to mention the next session that we have coming up in this series. So it will be on Friday, May 24th, same time, 12 p.m. to 1 p.m. Eastern Daylight Time. And our speakers for this session will be Maz Mohammed and Rakesh Ravindran from Mainikara XR Technologies, who will be speaking about Immersive Horizon, exploring extended reality and spatial computing solutions for Industry 4.0. So if that sounds like something you want to come to or that you want to watch, please mark it off on your calendar, and remember, keep sharing it in your networks to anyone who might find it relevant or interesting. Registration is always open and free for our lectures. And with that, I think we can wrap up the session. So thank you one last time to everybody.
Thank you very much.